My dear students, today I am going to discuss the next topic, part 2, that is 12th unit, coordination compounds, part 2. Vetri welcomes you. I am Dr. Gunasekaran, taking class for NEET original question paper discussion. So it is my duty, as usual, in every chapter I have to give introduction. So here coordination compound, or we'll say complex salt. When I say salt, how we are getting salt? An acid reacts with a base to form salt. So there are three types of salt. One is simple salt, example sodium chloride. Double salt, example more salt, that is ferrous sulfate, ammonium sulfate, 6H2O, and complex salts, potassium ferricyanide, K3FeCN6. So this is the types of complex. So these types of salts, when you come for the complex salts, I can further classify into 4 types. What are they? Just see here. In this case, one is simple neutral complex. Within square bracket, everything will be there. Outside square bracket, nothing. This is called simple neutral complex. Then, number 2, anionic complex. So whenever any salt, one is cation, another is anion. So in this case, potassium K3, that is cation, FeCN6 within bracket, it is anion. So it is called complex. FeCN6 is complex, so anionic complex. Cationic complex, so here CuNH3 4 within bracket, SO4 2 minus outside, so this is cationic complex. And both cases, cationic and anionic complex. In this case, chromium NH36, cobalt CN6. So here chromium acting as a cation and cobalt acting as an anion. Kindly follow. This is the types of complexes. So now let me go for the questions. Remember, I have already discussed in my previous videos the NEET question paper asked between 16 to 22. So now I am discussing 22 to 25. I am discussing part 1. I have already discussed 12A. This is 12B, part 2. So starting from 1 to 5, I have already discussed in the last class. And 6 to 10, I will discuss in this class. So now, 6th question in part 2. Match list 1 with list 2. Question asked in NEET 24. A. CONH35 NO2 within bracket, Cl2 outside. 1. List 2. Solvate isomerism. B. CONH35 SO4 within bracket, outside Br, 2. Linkage isomerism. C. CONH36 within bracket and again within bracket CrCN6. 3. Ionization isomerism. And D. COH2O6 is within square bracket, Cl3 outside, coordination isomerism. Choose the correct answer from the option given below. 1. A1, B3, C4, D2. 2. A1, B4, C3, D2. 3. A2, B4, C3, D1. And 4. A2, B3, C4, D1. The very interesting information here it is. You must know what is isomerism, what are the complex will exhibit isomerism, then only you can able to answer this question. So what is isomerism? Compounds having optically haptic compound having same the optically active the compound having same molecular formula, but difference in the structure giving optical activity. That's called optical isomerism. So normally, this in the case of complex, there are two types of the complex will show the isomerism. One is planar, square planar. Another is the octahedral complex will show the isomerism. In the octahedral, we can get the cis and the optical. In the square planar, we can get now cis trans isomerism. So now let me come for the now. So the interesting information now in cobalt, the configuration is 3D7 4s2. So automatically the complex here it is, there are ion 3 negative ion, so 3 electron will be released. So it should be 3 NH3, actually the 5 NO2. So this CO will be in the form of CO3 plus. So what will happen now? Ammonia, it is strong ligand, so that it will pair this. So when it is pairing means, so what will happen now? I can think of D6. Kindly follow. One, two, three, four. 1, 2, 3, 4, 5. So 3D 6. This is the actually cobalt 3 plus. The first one A. Kindly follow. So the ligand is NH3. It is the strong ligand. So what will happen now automatically? The outside, there is, we are having now 2 more electron is there. So what will happen now? That electron will now automatically pair this one. What way it will pair? This way it will pair. Just see here. So it is diamagnetic. Kindly follow. So now the interesting information here it is the choose the in the case of this it is diamagnetic. Kindly follow. So now let me go for the types of, because this is regarding the nature of the magnetic. Now, but we are interested only the isomerism. So in this case, if you take A, it is considered nothing but it is a linkage isomerism. Linkage isomerism. A2, that is A2, linkage isomerism. That means NO2 will be displaced by Cl2, linkage isomerism. The next one, B3, maybe it is an ionization isomerism. And C, both sides it is coordination isomerism. And D, it is solvate isomerism, a water molecule. So this is the actual, the nature of the isomerism. Let us verify now. So answer should be 4. Yes, this is the correct answer. So only if you understand the nature, you can easily identify. So A2, B3, C4 and D1. So this is the type of isomerism. So correct answer is A. Sorry, 4. Okay. Next question, number 7. Number 7, given this is asked in the year 24, NEET 24 asked. Given below are two statements. Statement 1, both CONH3 3 plus and COF6 3 minus complexes are octahedral, but they are differ in their magnetic behavior. This is statement 1. Both are octahedral, but differ in their magnetic behavior. Statement 2, CONH3 3 plus is diamagnetic, and whereas COF6 3 minus is paramagnetic. In the light of the above statements, choose the correct answer from the option given below. A, that is number 1, both statement 1 and 2 are false. Statement 1 is true but 2 is false. 3, statement 1 is false and but 2 is true, false. So, here both statement 1 and 2 are true. The interesting information here it is answer 4 is the correct. Let me explain how the 4 is correct. Kindly follow me. The idea, kindly follow, answer is 4 is correct. Let me explain the reason now. You take this ligand. Cobalt, we know already it is 3d7 4s2. 3d7 4s2. This is the original cobalt. So if you go for 3 plus means 3d7, that is 3d6. It is cobalt 3 plus. So ligand is a strong ligand. So what will happen now? It will pair all the 6 into 3. That means it is 1, 2, 1, 2, 1, 2. So this is D2 sp3 hybridization. D2 sp3. So 2 unpaired. So all electrons are paired. It is diamagnetic. So statement 2, it is correct. So both CONH3 3 plus and COFC 3 minus complex are octahedral. Octahedral means we know 6 ligand means it is octahedral. So statement 1 is also correct. Coming from the magnetic character, we have identified first one is diamagnetic. Let us go for second one, cobalt F6. Cobalt F6. So what will happen now? As usual, 3 plus, CO3 plus, that means 6. So this is the 6th ligand, but the ligand F is the weak ligand, so it will not pair, so there is 4 unpaired electrons. So 4 unpaired electron means it is paramagnetic. So the complex CONH3 3 minus 3 plus is diamagnetic. COF6 3 minus, it is paramagnetic. So magnetically they are different. So both statement 1 and 2 are true. This is the correct one. Question number 8. Please follow carefully. Which of the following are paramagnetic? Which of the following are paramagnetic? Nickel. Nickel means 3D8 4s2. So 3 nickel compound. All are nickel. So please follow, all are nickel. Only thing is we have to find out the nature of the ligand we have to identify. The question is whether it is paramagnetic or diamagnetic depending upon the nature of the strength of the ligand. Nature of the strength of the ligand. First one, chlorine. So what will happen now? Kindly follow. So that is nickel 2 plus, because 4 will minus 2 minus outside, so nickel 2 plus. Nickel 2 plus means it is 4s2 is over, so it is D8 will be there. One, two, three, 4, 5, 6, 7, 8. So 2 unpaired electron is present. Kindly follow. So it is paramagnetic. A is paramagnetic. Please follow. The next one. If you go for nickel, CO4, it's a tetrahedral. Kindly follow. So now let me take again the electronic configuration of nickel. 1, 2, 3, 4, 5. So it is D8, 4s2, sorry, 3d7, 4s2, that is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, that is nickel D8. Nickel D8, 4s2. So now from this is a neutral ligand, so it is all D8, 1, 2, 3, 4, 5, 6, 7, 8 filled, and 4 also 2 filled. Kindly follow. So what will happen now in this case? So the ligand CO, it is highly the powerful strength of ligand, so the on formation of complex, these 2s, 4s2 electron coming and pairing here, this is becoming empty. So all are, it is diamagnetic now. So nickel tetracarbonyl is diamagnetic, B. The same way, you go for C again, it is also strong ligand, it is also diamagnetic. The same explanation we can go. When you go for this ligand weak, as in the case of A, this will be also paramagnetic. Same explanation. Whereas this NiPPH3, it is diamagnetic. So answer is A and D will be the correct answer. So kindly follow now. So A and D is the correct answer. Next question. Question number 9. This is asked in NEET 25. NEET 25. The correct order of wavelength of light absorbed by the following complexes is CONH3 6 3 plus, B CONCN 6 3 minus, CuH2O 4 2 plus, and titanium H2O 6 3 plus. The interesting information here is choose the correct answer from the option given below. A, B less than, that is lesser, D lesser, A lesser, C. 2. B lesser A lesser D lesser C. C. 3. C less than D less than A less than B. 4. C less than A less than D less than B. The interesting information here, you must know the difference between wavelength and delta value. The crystal field splitting. This difference you must know. Generally, I can give you an example. E equal to SC by lambda. This is the general equation we have arrived from the atomic structure. That means greater the lambda, lower the energy, and vice versa. So, if the ligand is stronger, this crystal field energy will be higher, the lambda will be lower. So this idea you must keep in your mind and compare the complex, the strength of the ligand also. See, this is the very interesting information. The most probably I can suggest the answer may be 2 may be the correct answer. The reason is, see, H2O, it is the weak ligand. It's a tetrahedral weak ligand. C, D10, 3D10, 4S1 actually. So what will happen now? In this case, what is the weak ligand? So weak ligand means crystal field energy will be less. If it is very less, the lambda is higher. See, please follow the correct order of lambda. So higher lambda H. Coming for titanium, here again same ligand, but in this case scandium titanium 3D2 4S2. So what will happen? 3 plus means it will be only one electron. 3D1 will be there. So one electron means, so the field again the ligand is same, low crystal field ligand, but the only one electron, there is 9 electron. Correspondingly, the energy will be very, very low, but comparatively. So in that case, probably next may be the D. Now come for A, B and C. That is A, ammonia ligand, and C, CN ligand. CN is the strong ligand. Strong ligand means crystal field ligand lower lambda. So B is the lower lambda. Automatically A will be lesser lambda. Probably 2 will be the correct answer. So let me explain. Still, this is the correct answer. Kindly follow. So it is based on the valency electron in the crystal during the formation of complex, the orbit, the metal having the electrons and the ligands both depends on this one. So weaker the ligand, crystal field splitting will be low. Stronger the ligand, delta, it is larger, lower value. Based on this, 2 is the correct answer. The next question. That is the question number 10, the year 25, NEET 25. Out of the following complex compounds, which of the following will have the minimum conductance? Please follow. Minimum conductance. This is coming under the properties of coordination compound. Conductance means, listen me, number of ions are higher, conductance will be higher. Conductance will be higher. In the complex, outside the coordination pair only can be ionized. Inside coordination pair will not be ionized. So these 2 factors you have to keep in your mind. I hope clear. So now let me give some information. Kindly follow me. Number of ion produced by the complex, we must do. That is depending upon by outside the coordination sphere we have to think of. So outside the coordination sphere, number is more, the conductance will be more. If the number of ions are same in both cases, then we have to go for the charge of the complex. Say for example, this complex CO, that is 3 plus NH3 Cl3, CO2 plus NH3 4 Cl3 2. So in this case, both complex with have no charge. Therefore, both complex have the same conductance. Outside sphere, no, nothing is there. Coming over the third one, 3Cl, and here is 1Cl. So I told you outside the coordination sphere, so if the number of ions are more, that is the will show conductance, higher conductance, low number, low conductance. So kindly follow. Correct answer is 4. Because the first one, there is no the ligand outside the complex, neutral complex. This is also neutral complex too. So no conductance at all. But when you come for these three, we'll be having kindly follow. Question is minimum conductance. Here 3 chlorine, so maximum conductance. This is 1 chlorine, minimum conductance. So correct answer is 4 is the correct answer. I hope you have enjoyed well. So I will discuss the next 13th unit next class. Dr.R.G. Bye-bye.